guys. Yeah, I'm back. Welcome to my channel. We're gonna see. Oh man, that looks very. I need to start getting contacts because like the reflection off my glasses of the little ring light. But if I don't do the ring light, it looks a little dark in here because I prefer the yellowish kind of warm lights other than the daylights. So just well, welcome everybody. I know it's been a little bit. Things have been a little, not really. They haven't been hectic this time. Can you imagine that? Can you imagine that? Things have not been hectic. It's actually been okay. I just haven't been on for reasons. I don't know. I always feel like I have to justify it because I'm not that weekly streamer or something. But I don't know. Every time the time comes up, it feels like, oh my god, if you don't do it, you're gonna fail. You're a failure. And I shouldn't feel that way. But I do. So, here's me being a failure. Let's go ahead and get started. Happy holidays and Merry Christmas to everybody. We're gonna talk about evolution. Boom, boom, shrinking down because nobody wants to look at me. They want to look at this. Alright, let's get started. First article we have today. I hope this is, oh my god. Is it not working? Are you not working? Tell me you are working. I'm gonna be sad if it's not working. Let's see. Oh gosh, it is working. Ha ha ha. No audio issues today, just really shit quality. Okay. First evidence of early Neolithic archery from Cueva de los Murciélagos, revealed through combined chemical and morphological analysis. See this abstract? The extraordinary preservation of Cueva de los Murciélagos provides a... Oh, let's check out where this is. Carbuño, Spain. Check it out. Gotta look on a map. It's helpful. It really is. I found I kind of understand history and stuff a bit better if I have a map to follow along. I did it with Game of Thrones as well, like having that map in the front of the book. I think it was the front. Really helps. I don't know why. I guess I'm a visual person. See where it's at. Boop. Let's see. Oh, are you not gonna load? Come on, load. Uh-oh. I think I broke it. Ah, here we go. Ooh, that looks pretty nice and mountainous. Do you have, like, better quality? That looks pretty good. I don't think they do topos, do they? It's pretty mountainous. Okay. Pretty close to the water. Look at that. Sierra Nevada National Park. We are all the way down in southern Spain. A wonderful place to be. I've actually never been in southern Spain. I've been to Madrid, but not southern Spain. I would love to go. But time and money, you know, people, you gotta eat, you gotta have a house, you know, roof over your head, and you gotta work. And that's just to get the finances, and then you gotta work, so you can't have the time. Life. Anyways, now we know where it's at. It provides a unique opportunity to identify the materials and the techniques involved in archery during the early Neolithic period. Arrows with preserved feathers, tied fibers, adhesive substance, and 2 probable bowstrings have been studied through an unprecedented multi-proxy investigation, including microscopy and biomolecular methods to unravel archery techniques. The study has identified the oldest known sinew bowstrings, the first evidence for the use of olive tree and reed to produce arrow shafts in prehistoric European archery. Ooh. And the identification of birch bark tar as a coating on the shafts. The results of this study provide insights into ancient craft, technological solutions, and adaptations sorry. Oh, where was I? Technological solutions and adaptations to local resources in the production of these reed shafting hardwood-tipped arrows and bowstrings. Their deposition in a burial cave sheds new light on the role of these artifacts in a Neolithic farming community. The study of Neolithic archery has been primarily focused on 2 main aspects: projectiles and bows. Okay. When examining bows, a remarkable consistency in raw materials and production techniques is observed across different regions during the Neolithic. Well, I mean, if you find something that works, are you really going to fuck with it too often? Not really, when your life depends on it. Despite variations in size, the prevalent use of wood suggests a shared technological tradition throughout Europe during this period. This uniformity implies a sophisticated understanding and transmission of bow-making techniques among these Neolithic communities. Conversely, research on projectiles has unveiled a rich diversity in both raw materials and shapes. While the lithic and bone projectiles dominate the archaeological record due to their frequent discovery, there are also noteworthy instances of wooden projectiles as evidenced in waterlogged sites. This diversity underscores the adaptive strategies and resourcefulness of Neolithic societies in utilizing a variety of materials in their weaponry. Beyond the technical aspects, scholars have extensively debated the social and ideological significance of archery in the Neolithic context. Bows and arrows have traditionally been categorized as tools primarily utilized for hunting purposes. Hunting, however, may have played a relatively minor role in Neolithic subsistence strategies. The persistence of archery elements and the diversity of projectiles suggest that archery held significance beyond mere sustenance, possibly linked to rituals, warfare, and other socio-cultural practices. Well, why wouldn't it? It's skill, so social hierarchies there. I mean, you're gonna sit there and be like, hey, dude, I bet you I could hit that and you couldn't. I'm better shot than you. Like, of course that's gonna happen. And then for warfare, like, you really gonna run up and just, like, club someone over the head? No, if you can shoot them from afar, you're going to. Just because you used it on animals doesn't mean you're not willing to use it on a human being. Ooh, that could be bad. Moving on. For example, compelling osteological evidence has been found for their involvement in interpersonal violence during the Neolithic period in the Iberian Peninsula, Spain, including cannibalism as well as across Europe. Cannibalism. Other facets of Neolithic archery, such as the production of arrow shafts, remain relatively underexplored in the archaeological record. Factors such as the methods for affixing arrowheads to shafts, the materials and properties of the shafts themselves, and the characteristics of bowstrings have received scant attention, primarily due to the unlikelihood of such delicate remains preserving. Consequently, our understanding of these aspects largely relies on insights drawn from ethnographic studies and experimental archaeology. Okay? I got to do that. Well, not with a bow, but I got to make an atlatl, and it was fun. And I don't have any of the darts, but when I was in undergrad, and doing the like anthropology club, we got to make the atlatls, and then the professor had the darts for him. I've been meaning to make my own darts, but that was a decade ago? I'm not okay with that. And I've been saying since that I was going to make my own darts, and I still have yet to do it. My atlatl sits right on my shelf. Right there. Unused. I should be a hunter goddess by now. What am I doing with my life? The unique archaeological context of Cueva de los Murciélagos, I can pronounce things, offers new perspectives on the use of organic materials in prehistoric archery. A wealth of archery artifacts has been recovered from this cave, used as burial cave during at least the Neolithic. Preserved through desiccation due to the dry conditions within the cave, the material includes shafts and arrows along their associated organic components, including adhesive feathers and fibers. That is awesome. It's so dry in there. They just stay preserved. Such preservation provides a rare and exceptional opportunity to study elements ordinarily absent in archaeology owing to their perishable nature. With the exception of a fragment of cord found during the recent resumption of excavations. The artifacts were discovered by miners in the 19th century, and no information is known about their surface provenance. Furthermore, all of these objects were found deposited in the cave, unstratified, which poses a challenge for the reconstruction of possible different funerary events that may have occurred at this site. Let's see what I got. I like figures. These are nice. Plant-based arrowheads and shafts. A is a reed and wooden arrow shaft. One detail of white adhesive and tied fibers at the junction between the reed and wood. Okay. Very nice. B is another shaft. B1 to 4 is the arrow notch with feathers, tied fibers, and black adhesives. Feathers? I don't see feathers. Maybe that's it right there? That's a feather? Okay. What do we got here? Some string. Cordage fragments from the cave, identified as possible bowstring. A1 is a knot repair right there. Detail of twisted fibers. Broken fringed cord end, and detail of twisted fibers with organic materials between the grooves. So the radiocarbon dated it and got what? Probability distribution of radiocarbon dates, including those from this study in blue. And previously published dates, multi-phase Bayesian chronological ranges for the estimated start and end of each phase, and modeled ranges of each radiocarbon date. Subjects studied in this paper are in blue. So we got here, 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 and here. What is the red? Did I see? Okay. Oh, way over here. Whoa, look at that. That one's way off. By a lot. Wow, why is that one so off? What happened there? Branches were debarked and polished as not cut marks or other traces were observed. This group is dated to the early Neolithic. What is this? It is UA. I don't think it's going to talk about it. Ooh. Microphotographs of wood artifacts. Look at that, that's cool. Okay, identification of fibers. Ooh, what do we got? Observer made with the optical microscope of 2 cords, and from the ties of the shaft led to the conclusion that the fibers were not of plant origin, as none of the observed characteristics correspond to those of a plant organism. The cords were then analyzed with SEM, however, the anatomy of the ties were more difficult to observe because they were held together by an adhesive substance which could not be completely separated from the fibers before microscopic examination. Parallel fibers in the longitudinal length were better observed on the 2 cord samples, revealing the hierarchical structure of undulated fibers, composed of smaller fibers, which is similar to the structure of collagenous animal tissue. Look at that. It's up here. Moving up to those pictures. Boom! This animal. I should probably check to make sure nobody's trying to talk. Nope. Okay. Hi, everybody who is not here. Moving on. What do we got? Okay. Let's just go to a conclusion, shall we? This is a lot. And if you ever want to reread the articles I go through, or follow up, or look into what the researchers may be doing as well, I post all of the articles and all of their links into my Discord. So if you are interested, join me on there. Methods. Gotta tell them how you did it. But they have data availability. Analyzed during the current survey will be available from the Zenodo repository under DO. Oh, that's so cool! You can request them from the authors. Oh my god, that's so cool. I like that. Moving on. Moving on. Let's see. Influence of age, sex, and season on hematological parameters in a captive population of former laboratory chimpanzees. This study aimed to establish a baseline hematological profile and examine the influence of age, sex, and season on hematological parameters in captive chimpanzees living in a humid tropical climate. Hematological parameters are a useful tool for assessing health status and diagnosing diseases in animals. We analyzed 473 blood samples collected from 84 chimpanzees, 43 females and 41 males, during annual health checks conducted under anesthesia for a routine physical examination. Do you just shoot them with a dart gun? Probably. Poor monkeys. They're not monkeys. Poor apes. Don't call them monkeys. They're apes. Poor apes. Age-related variations have also been noted, with adolescents and adults having lower lymphocyte counts but higher neutrophil and monocyte counts than infants. Adults in particular had significantly lower platelet counts compared to other age classes. Seasonal fluctuations were also observed. Lymphocyte counts were higher in the rainy season, while neutrophil counts were higher in the dry season. In addition, the general trends in hematological parameters for this captive population of chimpanzees were similar to those reported in captive chimpanzees living in the United States. These results should provide animal health professionals, particularly those working with non-human primates, with data to compare and interpret. They will help improve practices for monitoring and managing the health of non-human primates in captivity. The study establishes the baseline profile. The The study highlights significant differences in certain... Okay, I just want to know what you found. The study found significant age-related variations. Okay, but you just talked about... in the abstract, it just talked about adults versus infants. I want to know a little bit deeper. Does an old chimp have much of a difference than a young chimp? Curious. Seasonal variations. Okay. Data available statement. This data that support the findings of the study are available from the corresponding author upon reasonable request. You just gotta ask. What did my friend say? Closed mouths don't get fed. Closed, not clothes. Closed mouths. Do cultural and biological variation correspond in the Middle Nile Valley Neolithic? Some insights from dental morphology. Broad cultural similarities are apparent between Neolithic sites across Middle Nile Valley, yet local variation may also be witnessed. The dearth of well-preserved skeletal assemblages in this region means that biological connections between populations and thus potential modes for the transmission of material culture are not well understood. Here the authors compared dental morphological traits in 5 Neolithic cemeteries between 5,600 years to 3,800 years BC, and 14 times successive sites to explore biological relatedness along the Middle Nile Valley. Their findings parallel the artifactual evidence suggesting that the spread of the Nubian Neolithic may have been as nuanced as the populations who practiced it. During the Neolithic, the land along the Nile River and the adjacent deserts from the first cataract at Aswan is the confluence of the Blue and White Nile rivers near Khartoum. Collectively termed the Middle Nile Valley, was inhabited by pastoral societies. Their varied economies relied on the husbanding of domesticated cattle and caprines, hunting, fishing, and the intensive foraging of wild plants. Archaeological research in this region is limited but suggests that, alongside hunting, the intensive collection and processing of wild plants was already practiced by foragers near Nabtalia in Egypt's western desert by the 7th millennium BC. The practice of cattle keeping, which likely predates sheep and goat in northeast Africa, is thought to have arisen in this same area. Before expanding into Upper Nubia and Central Sudan, over the subsequent 2,500 years, different Neolithic pastoral groups lived across Lower and Upper Nubia and Central Sudan. Sites that have been excavated contain the remains of rich and diverse material cultures, but wind erosion and changing burial customs have contributed to the poor preservation and underrepresentation of human skeletal assemblages in the Middle Nile Valley. Thus, until the early 21st century, little was known about the people who had lived in this area and the biological relationships between groups across time and space. Over the past 2 decades, skeletal remains have been recovered from 5 Neolithic cemeteries in the Middle Nile Valley, dated to the late 6th through the first half of the 4th millennia BC. Gebel Ramla in the Western Desert, Lower Nubia, and just as Lower Nubia, Western Desert, Lower Nubia, R12 in Upper Nubia, and in Central Sudan, Kadero. Gaba, and Al-Kidai. Ancient DNA does not preserve well in this part of the world due to heat degradation, but consideration of dental morphological data allows an insight into the biological affinities of populations. Combining new dental data from Kadero with published material from the other 4 Neolithic cemeteries, we address the following question. Does archaeological evidence for generalized cultural similarities in the Neolithic equate to comparable biological affinities? In other words, did Neolithic practices spread as a result of population migrations into Upper Nubia and Central Sudan? Our investigation builds on existing bioarchaeological research, directly testing such a link in varied world populations, and in Nubia in particular. The early dates for cattle at Nagtaplaya and nearby Burkiseva and Gebel Ramla support a geographic origin of the Nubian pastoral Neolithic tradition in the Western Desert. By the early 5th millennium BC, sites such as El Gaba and later Kadero in central Sudan had artifacts and practices like Nubia, suggesting a shift southward of population. Prospective cultural commonalities throughout Nubia and central Sudan are then evident during the later Neolithic in pottery manufacture and form. Lithic and ground stone technologies, personal adornments, funerary traditions, and, as previously noted, practices of animal domestication and intensive plant collecting. The most striking commonality may be the exquisite caliciform breakers found across Egypt, Nubia, and central Sudan. While not identical, beakers from Gebel Ramla share similarities in manufacture, shape, decoration, and exclusive presence and burial to those others further south, especially narrow-fluted variants at R12, Kadruka, El Gaba, and Kadero. Burials are also largely uniform in this region during the Neolithic. The deceased were interred near habitations in round oval pits shortly after death, as indicated by the flexed position and full articulation of joints, and placed on their side in a contracted position. Figure 3, showing how they're dead. What is this? Oh, that's the beaker. Accompanying artifacts were plentiful in some burials, but in others they were few or absent, perhaps implying social stratification. Where present, goods include beakers, other pottery, groundstone, lithic and bone weapons and tools, personal adornments, marine and freshwater shells, pallets, mica sheets, polished pebbles, pigments, and animal horns. Though these cultural commonalities are apparent, the lack of consistency in regional terminology impacts the interpretation of relative regional chronologies. Local cultural variations are also apparent in pottery and lithic production across Nubia, and particularly in comparison with central Sudan. Beyond the general similarities in burial arrangement, regional and temple differences are patent. These and other variations reflect a cultural dynamic in later Neolithic and Middle Nile Valley that is currently receiving the attention it deserves, as evidenced by the preceding references. Against this backdrop, this article has two objectives. First, to investigate the extent to which Neolithic material, culture, and practices parallel biological population affinities in the Middle Nile Valley. Second, to explore whether the proposed spread of pastoral Neolithic from Lower Nubia and its eventual cross-regional manifestation resulted from 1. The migration of pastoral populations, 2. Cultural diffusion of the toolkit in practices, or 3. Both. Both objectives may be addressed statistically through hypothesis testing, specifically testing the null hypothesis, that there are no significant differences in ductal morphology between Neolithic populations, against the alternative hypothesis that there are significant differences between one or more Neolithic samples. While further research across different fields is needed to conclusively address both objectives, the present approach should yield some useful insights for future studies to build upon. Okay, don't want to go through the methods. Ooh, a picture. Slight incisor shoveling. Interesting. And then the cerebelli cusp. Okay. So it tends to be genetic. The shoveling of your front teeth, so they kind of, like a shovel blade, they're kind of concave a little bit. It's genetic. Some people have it, some people don't. If you just kind of, I'm sure you know what your teeth on the inside feel like, but a lot of people don't have that. I am one of them. I do not have shoveling on my incisors. And then the cerebelli's cusp are these little tiny like pseudocusps that can happen on molars. I do have one of those. Yeah, my upper molar on the left. Results. Let's see. Percentage presence for the 36 traits in the 19 population samples were submitted initially to the MMD to provide a distance matrix that is visualized in Figure 6. Uniformity among samples is implied by a review of the percentages and the relatively low MMDs. Okay. Cool. The null hypothesis that there are no significant differences in dental morphology between one or more of the Neolithic samples from the Middle Nile Valley, this is what I want, can be rejected. This supports the question of whether overall cultural similarities, though the regional differentiation equates to comparable biological variation between Lower Nubia, Upper Nubia, and Central Sudan. Analysis of ASU-DAS traits shows that biological affinities among Neolithic populations from Upper Nubia and Central Sudan are more nuanced, and close biological parallels cannot be entirely ruled out. A scenario involving the southward spread of the pastoral Neolithic through population migrations from the Western Desert origin is neither fully supported nor fully rejected by the available data, and a degree of cultural diffusion may be implied. Further work with dental and other bioarchaeological data and the compilation of cross-regional chronologies is necessary to better understand Neolithic populations across the Middle Nile Valley. But the work presented here provides useful insights for ongoing study. More broadly, this work reaffirms the need for joint consideration of archaeological and biological evidence when researching ancient populations, and serves as a reminder that the inability to obtain ancient DNA does not necessarily preclude analysis of relatedness. Oh, that conclusion! That is the most classic conclusion. Like, we can't say yes or no. We know it's not no. We can't say it's a lot. Maybe. More study needs to be done. We need more data. Woo! That is classic, isn't it? Nice, I like it. Thank you very much to Joel Irish and Jacek Kabasinski. Sorry if I butchered your name. Probably did. Let's be honest. Chimpanzees perform the same complex behaviors that have brought humans success. A new study suggests that the fundamental abilities underlying human language and technological culture may have evolved before humans and apes diverged millions of years ago. The findings will be published December 5th, 2024 in the journal PeerJ. Many human behaviors are more complex than those of other animals, involving the production of elaborate sequences such as spoken language or tool manufacturing. These sequences include the ability to organize behaviors by hierarchical chunks and to understand relationships between distinctly separated elements. For example, even relatively simple human behaviors like making a cup of tea or coffee require carrying out a series of individual actions in the right order. Boiling the kettle before pouring the water out. We break each task down into solvable chunks. Boil the kettle. Get the milk and tea bag, etc., composed of individual actions: grasp, pull, twist, pour. Importantly, we can separate related actions by other chunks of behavior. You might have to stop and clean up some spilt milk before you continue. Hopefully you clean up the spilt milk. Some people do not. It is unknown whether ability for flexibly organized behaviors in this way is unique to humans or also present in other primates. In this new study, the researchers investigated the actions of wild chimpanzees whilst using tools and whether these appeared to be organized into sequences with similar properties. The research was led by the University of Oxford with an international collaboration across the UK, US, Germany, Switzerland, and Japan. The study used data from the decades-long database of video footage depicting wild chimpanzees in the Bozu Forest, Guinea, where chimps were recorded cracking hard-shelled nuts using a hammer and anvil stones. This is one of the most complex documented naturally occurring tool use behaviors of any animal in the wild. The researchers recorded the sequences of actions chimps perform. Grasp the nut, pass through hands, place on anvil, totaling around 8,260 actions for over 300 nuts. Are cracking nuts really the most complex? Don't we have videos of orangutans spearfishing? Using state-of-the-art statistical models, they found that relationships emerged between chimpanzees' sequential actions, which matched those found in human behaviors. Half of adult chimpanzees appeared to associate actions that were much further along the sequence than expected if actions were simply being linked together one by one. This provides further evidence that chimpanzees plan action sequences and then adjust their performance on the fly. Understanding how those relationships emerge during action organization will be the next key goal of this research. But these could involve behaviors such as chimpanzees pausing sequences to readjust tools before continuing, or bringing several nuts over to stone tools that are then cracked in one long sequence. This would be further evidence of human-like technical flexibility. Additionally, the results suggest that the majority of chimpanzees organize actions similarly to humans, through the production of repeatable chunks. However, this result did not hold. I'll be right back. Sorry about that. I had to take it. It could not be helped. Additionally, the results suggest that the majority of chimpanzees organize actions into chunks, did not hold for every chimpanzee, and this variation between individuals may suggest that these strategies for organizing behaviors may not be universal in the way they are for humans. Lead researchers Dr. Elliot Howard Spink, formerly Department of Biology at Oxford, now at the Max Planck Institute, said the ability to flexibly organize individual actions into tool use sequences has likely been key to humans' global success. Our results suggest that the fundamental aspects of human sequential behaviors may have evolved prior to the last common ancestor of humans and chimpanzees, and then may have been further elaborated on during subsequent hominin evolution. Co-senior researcher Professor Theobald Gruber, Hans. There has been a renewed interest in the coevolution of language and stone tool use in human evolution, and our study contributes to this debate. While the connection between our results and early hominin stone tool use can be made more readily, how this connects with the evolution of other complex behaviors like language remains an exciting avenue of future research. Oh, that's exciting. Okay. I would not have thought to look that in depth and doing chunks. for actions to make a cup of coffee. Last one, guys, last one. Homo sapiens, Neanderthals, and speciation complexity in paleoanthropology. Tracking the origins of new species and delimiting taxa across space and time present well-trodden sources for controversy for paleoanthropology. Although biological diversity comes with frustrating, elusive boundaries, the task of describing and understanding diversity remains no less crucial, and paleotaxonomy no more dispensable. This is epitomized by the recent developments in discussions on our species' origins and the extent to which Middle Pleistocene hominin forms represent distinct lineages. While it is tempting to think that progress in such debates is only hampered by the paucity of fossil and genomic data, we argue that problems also lie with unrealistic assumptions and theory. In particular, we examine ongoing discussions on whether H. sapiens and Neanderthal deserve distinct species status as means to advocate for the necessity of reframing speciation in paleoanthropology in a more biologically plausible way. We argue that available paleontological evidence is best interpreted under a framework that sees speciation as an evolutionary process that starts in space, thereby involving a geographic dimension, and progresses in time, thereby involving a diachronic dimension, with an incremental accumulation of relevant characters at different phases of the process. We begin by discussing evidence about species-level differentiation of H. sapiens and Neanderthals, and analyze major sources of taxonomic disagreement before illustrating the potential for this perspective in making progress on the earliest stages of H. sapiens speciation within Africa. Accepted manuscript. Let's see. Oh, look at that, that's cute. So, Andrea Meneganzen and Chris Stringer. Okay, move on. Questions surrounding the origins and evolution of our species, Homo sapiens, have long been on the agenda of paleoanthropological research. Yet, this topic has hardly become any less relevant today than it was half a century ago. While it can then be tempting to deem recurrent questions as a sign of stagnation and repetition within a discipline, reiterating the same questions against novel data and analytical tools can drive the development of more nuanced models and finer-grained versions of the original puzzle. We have more data now. Debates on the origins and evolution of Homo sapiens and its relationship with other covial hominin forms, most notably the Neanderthals, instantiate this pattern most glaringly, and will be at the core of this paper. It is through this iterative questioning that we have reached a broad agreement that we are a species with a recent, mostly African origin, and shared the planet with at least 5 other hominin species, and with some of which we interbred. Besides the Neanderthal, these include Denisovans in East Eurasia and island Southeast Asia, late Homo erectus, the diminutive species Homo floresiensis, and Homo luzonensis in island Southeast Asia. And looking at some of the earliest stages of our speciation in Africa, Homo naledi, Homo heidelbergensis, and Homo rhodesiensis. As a consequence, the scope of the debate moving within the RAO framework has become more wide-ranging and ambitious. Regarding early Homo sapiens history, we now want to get a better grip on plausible scenarios of divergence and migration across the African continent. Further, outside Africa, we want to focus on the dynamics of interaction of different hominin lineages in Eurasia to model their biological and cultural outcomes. Paleotaxonomy and models on species origins should aid in the description and analysis of hominin diversity and macroevolutionary patterns, supporting rather than distracting from relevant biological questions. So what prevents us from gaining even more nuance within this picture? This paper suggests that while the relative scarcity of fossil and genomic data is partly to blame, some fundamental hindrances lie with theory. Disagreements about hominin taxonomy and models of Homo sapiens origins in Africa appear to come down to assumptions about how the speciation process works and how to track this in the paleontological and molecular records. Here we suggest that we make further progress on these problems. Discussions on how speciation is modeled should be foregrounded. Indeed, speciation in taxonomic practice and paleoanthropology have long entertained a complex dialogue with evolutionary theory, with the record often being interpreted against biologically unrealistic expectations. While we are not alone in advocating a more critical reflection on the speciation process and its impact on hominin taxonomy, here we discuss a framework for speciation to guide the integration of different evidential strands and the interpretation of morphology in Homo sapien origins. This paper is structured as follows. Section 1 will provide a theoretical discussion of speciation in the fossil record, emphasizing the importance of considering speciation stages in chronological explicit context. Section 2 will address species delimitation in light of this view, drawing a discussions on Homo sapiens and Neanderthal species status as an illustrative case of recurrent points of contention. Section 3 will discuss arguments favoring a lumping move and highlighting sources of taxonomic disagreement. Section 4 will outline the implications of spatially explicit and temporally extended framework of speciation for the initial phase of Homo sapiens speciation. Section 5 concludes. I want to go to Section 4. We're going to jump all the way down. Section 4. Probably should read all this, but I'm not going to. Well, I will, but not on camera. Let's see, where is Section 3, Section 4, Homo sapiens origins. The perspective discussed above bears important implications for the developing debate on the early stages of Homo sapien origins within the African continent. While several proposals are now emphasizing the complex dynamics at the roots of our lineage, these are rarely discussed against the backdrop of speciation theory. Yet, assumptions on how H. sapiens speciation has probably occurred are certainly at play, and we believe an explicit framing would make available evidence less prone to multiple, undetermined interpretations. In this section, we delineate open issues and directions for future research. Proposed models of Middle Pleistocene evolution in Africa available range across a spectrum from a simple single origin model, where all derived traits of Homo sapiens emerge from a single localized ancestral population, to the Pan-African model, which posits a polycentric origin of H. sapiens automorphies within a highly structured metapopulation distributed across Africa and connected by gene flow. It has become increasingly clear that a simple single origin model excluding multiple ancestral contributions prior to Homo sapiens differentiation is theoretically and empirically simplistic, being especially at odds with demographic models best explaining patterns of present-day genetic diversity. However, the scattered African fossil record from the 400 to 200,000 years ago time range, combined with these models, does not yet possess the resolution to discriminate among different scenarios underlying the observed timescale and patterns of shared genetic ancestry. A recent study has concluded that the earliest genetic divergence among contemporary human populations dates to 110 to 135,000 years ago, and that despite the challenge of discriminating between demographic configurations prior to that temporal threshold, a higher likelihood can be attributed to a scenario in which the population ancestral to all present-day humans results from the merger of two stem populations, with experienced both gene flow between them and an extended period of drift, rather than one-sidedly supporting long-term population structure. This seems to be the best interpreted as a mixed model, combining elements of multiple ancestral populational contributions. with more recent times of population divergence, as postulated by models of geographical expansion from more localized sources. This scenario resonates with earlier proposals from phenotype-based phylogenetic modeling and theoretical analysis emphasizing a complex and prolonged evolution of Homo sapiens, including a phase of phenotypic differentiation among dames of late middle Pleistocene hominins, followed by a dynamic phase of fragmentation, mixing and coalescence into a more derived hominin form at more local scales. The time depth of current human population structure is, however, prone to continuous reevaluation. Approaches aimed at reconstructing current human genetic ancestry can yield different estimates due to distinct modeling assumptions. Cool. What's next? Summary and conclusion. That's cool. Let's read the conclusion and then we're done, guys. In this paper, we have argued that emphasizing the study of speciation within its temporal and geographic context is crucial for better framing and potentially reducing taxonomic conflicts in the paleoanthropological investigation of our species' origins and Middle Pleistocene diversity. These conflicts are often rooted not only in limited evidence but also in insufficient theoretical foundations. We began by outlining a framework for studying speciation in paleoanthropology, drawing from broader paleontological discussions, and applied this framework to the issues of species delimitation. By examining the species status of Neanderthals and Homo sapiens, we tracked speciation progression through various stages, as inferred from different available evidential strands. We identified a major source of taxonomic controversy in the lack of evolutionary and chronological contextualization of observed patterns of variation. Finally, we proposed future research directions focusing on the earliest stages of Homo sapiens speciation, emphasizing the need to address the mechanisms of early species formation and their underlying evolutionary geography. The origins of Homo sapiens and our interactions with contemporary hominin forms are subjects of ongoing debate and reconfiguration. In this dynamic field, where the interpretation of both past and novel evidence is often contentious, explicit theoretical frameworks are essential to avoid investigative deadlocks and productively move research forward. Oh, there's sources. Look at all the sources. I love it. So many sources. Yeah. Alright, well, that's all I have for you guys today. Check to make sure. Oh, hey, Drewski, how's it going? I was just getting ready to leave for the day. Yep. I hope you guys enjoyed the articles I covered. Don't forget, I put them on the Discord if anybody is interested in following up, rereading, or even looking into the researchers. Usually they have quite a few articles and books that they've written. I know that last one, no, where is it? I forget the first name. Andrea Meneganzin and Chris Stringer. Chris Stringer, big name. So you'll find a lot of information from him if you're interested in looking him up. Anyways, I have the Twitter if you guys are interested in Twitter. I guess it's called X now. I should stop calling it Twitter. I don't like calling it X. It's just Twitter. It was good. Yeah, anyways, I hope you guys enjoyed your evening, and I will see you guys next time.